Good day, folks. I'd like to talk to you today about solid state generators. I've demonstrated them on, and a lot of people, specifically in the beginning, were asking the information about my square wave generator, how I hooked everything up, and I never quite dedicated a video just for that. And I thought it would be appropriate because in my latest videos I was using the pulse controller to limit the current. So I want to show how I implement that in the circuit form here. So with that said, let's start here. I already actually demonstrated something like this maybe a few months ago, but not a lot of people saw the video because it was not directly related. It was kind of like, oh, I'm doing this, by the way, like halfway into a video, and without putting much emphasis on it, moved on to another topic. But it was basically gold, and I should have known to spend more time on it. But when you're focused on something else, I just led to other things. So back to this for a moment here. So right now I have the basics of the solid state generator of what I've came up with so far, folks. And what I want to do is I want to limit the current in our input. So here's for now a 9-volt cell battery, one 9-volt battery. And here's the square wave generator, which you could use any one you want. You could build, if you know how, your own 555 based generators. But I thought it was a lot easier to just buy the module for a few dollars. And it's got an up and down, and I could select the pulse cycle. So I want a really sharp, so 1 or 2% duty cycle on the square wave, just to pulse an NPN transistor here. So this is the pulse output here, which is a typical setup for an NPN. R1 for the base resistor. Don't hold your breath to it. I just guessed this, 96K. You see, transistors, folks, this is why I hate them. Yes, we use them as switches, but they are not always the strict on and off switch we want in some of our circuits. And I understand a lot of people know this already, they understand this, but some people who are just beginning don't. And what happens with transistors is, depending on the specifications, which you have to find out in your transistor model numbers, you can find out in the data sheet online, but let's say the typical voltage would be 1.5 volts for the base voltage. So that's like optimal saturation mode of the transistor, which will turn it in a fully on mode. Now what happens is, if you give it a little lower, like even half a volt, it will slightly turn on, but not fully on. You see, so if we have the wrong resistor value, we may not be fully turning on our transistor. And on the other hand, if the resistor value is too low, we might be driving our transistor in oversaturation mode, which that on its own will lead to a whole whack of other problems as well. So you have to really figure out what the sweet spot of your transistor is for a full on, without using too much voltage and without using not enough at the same time. So with that said, plenty of information out there to figure that out. You can even start off by using a variable here and carefully fine-tuning. Some Bedini motors actually have a variable in front of it just for convenience. Nothing wrong with that. So with that said, this is what I like doing. My square wave generator takes 40 mA. That's the current input. I already measured it. I know it takes this much. So it's a not bad sacrifice for a trigger to lower. So this is not complete on its own. What we want to do is we want to use it to switch, like I was using here, anything you want. For example, here's a high voltage module here. And this will run as low as a 1 volt input drive. But let's say, there's 100 milliamp left in your battery. Just like that, this thing will like eating it up. So it will even use a watt or two if you put it like on a fully charged 6-volt battery. So even though they will work at low current, if you give them high current, they have no problem in using it all, which is counterproductive in what we want to do. So the way around this, whether it was an ionizer module or one of these, is I want to pulse the input with the help of this at a very low duty, because this is how we can limit the current to just a few milliamps. In another video, I had it measured using this method with the help, you know, it was getting 45 mA. That's with the generator and the pulse controller, which means that I was limiting the whole generator using only 5 mA, and I was getting 150,000 volts. So this is great dealing, and this is the idea. Pure potential is what we want here to trigger our fields. So with that said, how do we implement this? So this is our controller. So we're gonna have our high voltage module right down here. We'll call this 150 kilovolt high voltage pulse generator. Here's our plus and our negative pulse out. So this is pull output. And this is our input here, which could be as low as 1.5 volts, and on mine as high as 6 volts. So we'll just put 6 volts DC for now, plus here, negative here. So how do we energize our high voltage module right here? So we'll connect this now. But let's add another battery right here. And this is Tom Bearden, when he talks about asymmetrical regauging and having it nonlinear and creating these imbalances, this is exactly what we're going to do. And we're going to create a lot of asymmetrical systems here, and that's a key. So I'm going to show you. And at the same time, people were having a lot of questions about isolation of Bedini and solid state generators, and we're trying to use transformers and other methods. If you put the diode, the reverse diode direct, you short it out. If you put the wrong isolation transformer, there's too much loss, and people were just having a hard time figuring out the balance without actually losing the gains you get of just charging one battery, like, or two for the price of one, like Bedini was doing. So here's our minus, here's our plus, here's our minus here, here's our plus there, and this is our 9-volt cell. It has a second battery here. So this battery here is going to control our generators. So we're going to set up our wire here. I'm trying to make this half neat here, folks, so bear with me. So this is our plus, which goes here, and we're going to pulse our negative over here through the transistor, and see how we're kind of isolating everything here, folks. Very important as well. So what we're going to do is we're going to connect this to our negative here, which is the emitter, like that. And our collector, we're going to switch our negative over here. Put a little lump right there. Bring this down there. And there you go. Like that. So now, as you see, we're limiting our current to maybe, we'll say that the input here is 5 mA. And we're limiting it with the square wave here. If you'd want to drive, you know, more of a DC, you can just put a small capacitor here, which will charge, we'll call it C1, which will charge quickly to the pulse and give it just enough, even that half a volt, to drive it and still get our 150 with near zero current. The whole idea is to not drain the whole battery in 10 minutes till it gets really warm. I don't know if anyone else has had these modules, but when you connect them even to a 9-volt battery, after 5-10 minutes they actually get hot. So this will prevent that and give us our continuous field that we're looking for. Now, this is not done, right? There's more to it. So this would be the equivalent in the Bedini. This would be our output right here. In the Bedini, it would be the back EMF out, but in this module, it's all integrated, and they have a flyback and voltage multiplier. So there's already a bunch of capacitors in here. So when you get a pulse, you're already getting a capacitive discharge. So we don't have to build that mechanism, assuming you're running one of these. But if you're going to run a Bedini, you're going to need to extend, have a real cap dump circuit. We can simplify with the module here. I'm trying to find ways that are practical that could work for everyone here. So now that we have our output here, what I found works good here on the negative side is the gas discharge tubes. So you put a gas discharge spark gap tube. I find that the 90-volt ones are actually very good. So when the capacitors inside of here through the voltage multiplier stage reaches 90 volts, bang, it triggers the gas discharge tube, and this will discharge a system. This is where it gets interesting, folks. And this is where I'm going to offer you a completely unorthodox solution, which is very interesting. So what we're going to do is, I'd have to draw something separate over here, which is not part of the circuit, to first explain the logic here, okay? So just ignore, because I don't want to wipe it out right now, because I'm going to go back to it. But just ignore the circuit for now, and I'm going to produce a new one in here, okay? So let's say we have 3 9-volt cells right here, okay? So we're going to go plus, minus, plus, minus, plus, minus. So typically if we would want to run, the series or parallel configuration, right? Which means that it would be pretty easy. Minus goes to plus, minus goes to plus, and then we connect our load here, like this, and our light bulb shines, right? And it's the 9 plus 9 plus 9 is the total voltage that the system, the light bulb, would see. So 9 volts, 9 volts, 9 volts. So 9 volts times 3 would be the total potential the battery would see. Totally understandable, right? But what happens when we change the configuration here? Let's go minus, plus, plus, minus, minus here, and plus here. Haha, something really odd, right? You're going to say, wait a minute, that's not how we run series circuit. You're completely crazy, Joel. What are you doing here? That's because they're thinking in traditional electrodynamics. And you're going to tell me right away, even though this is going to work, it's going to be counterproductive because the battery in the middle is not going to contribute, obviously, to the current output, but it's actually going to add internal resistance a little bit anyways. So you're actually going to be counterproductive versus just running 2 batteries. And the reason that works here, plus to plus here, minus to minus. So here we have our minus plus, we have our light here, but the difference is the light is going to see the potential of this one here and this one here. So it's going to be 9 plus 9, which is 18 volts. So it's going to see 18 volts, and because they're all assuming brand new at the same voltages, the plus and plus here, and negative, negative, they're the same potential, so they cancel each other out. You get 0 here. So that's why you don't get an actual, it's actually partially isolated over here, even though it's part of the circuit, because it doesn't contribute the current in the traditional sense to the system. So now you're probably going, aha, I think I see where he's going with this. So, back to our system over here. Let's add a third battery right here. This is 9 volts cell right here. But what we're going to do is we're going to go plus here, minus here, and we're going to connect it to this system right here. So we're going to go plus is going to connect with the plus here, and the negative is going to go ahead and connect with the negative here. So essentially, you know, as far as every system is concerned, this one here is running this one here is running this here. But now that we have this system, we want to take advantage of it, right? So we're going to change a little bit the way the circuit goes now. So what we're going to do is we're going to run it off the 3 batteries is actually going to be what gets pulsed. So our plus here is going to be this one here, like I actually had it. I don't know why I did that, but okay. And then the negative, instead of being this one here that it's pulsing, we're going to disconnect this negative here, and we're going to go right to the negative here. So you see now, this battery only is running this at 40 mA. We're really breaking the symmetry, folks. Tom Bearden would really be proud. This one here is running, well, it's not running anything directly actually, it's just part of the 3 battery series configuration, but the high voltage module is now connected to this one and this one. It sees the 2 battery, it ignores this one, it sees 0 here. But again, we're not dumping the load here, we still have the 90 volt discharge. So what are we going to do? We're going to put our plus here, it's going to charge the battery right here. The negative is going to dump, into the second battery. I can do better than that. I don't want to confuse people here. There we go. So now the minus is charging the second battery. So that the high voltage at 90 volts is charging this battery here. So this totally breaks how it would work in traditional electrodynamics, because you see what's going to happen now is as this battery here starts increasing voltage, it may read 9.1 volts, while this one here or that one here, let's say the first one drops a little bit. Whichever one is lower, which is really cool because this is automatic sensing, regauging without any auto compensator circuits. It's just doing it with nature basically. So what I'm getting at is now instead of seeing 0 here, it's going to see the plus whatever 100 millivolts, and it's going to start distributing that into this battery or that battery. So it's fully isolated, but it's not, you see? So now these 2 batteries are going to be able to charge. See what I'm getting at? It solves the isolation issues of sending it back without having to worry about transformers. Let's say this was a Bedini, this would work as well with the Bedini setup, which is really interesting. Now, if you want to take it one step further, this is a little bit more complicated because it's a high voltage module, but let's say this is actually a Bedini. We'll call this Bedini instead. Bedini. So we're using a traditional Bedini here. What's interesting with the Bedini is the way the wheel works and the magnetic pulse. It's not a auto self-triggered system. It needs that pulse to start it. So you actually get a pause in the input current. So what I'm getting at is the Bedini motor also switches your CEMF. So all you have to do is on the plus side here that's feeding the Bedini, you had an additional transformer stage here with L1, and here would be L2, and I've shown this in another video. And you're also, and if you want to get really creative, use resonance, tune to your frequency, even add a reactive stage if you want to put a capacitor in there as well. C1, so now you've got an LC circuit that's also increasing the potential from the CEMF trigger. So you're really taking every system here and recycling it, and then the output of this can be then rectified with the help of the diodes back to DC, which can then charge. I'm running out of space here. The first battery. So now we have a system very similar to that Bedini's later motor with the hub edition, the hub motor he called it. Every battery is getting hit with an incredible amount of power and using hardly anything. We've created a very non-linear system. We're doing asymmetrical regauging and we're breaking the symmetry like Tom Bearden's doing, and we're doing it by using very little input trigger, just by the, this is very ugly, I know if you wouldn't follow me by now you wouldn't know what all this means, but my point is you've got 3 batteries and you've got a system inputting high voltage in all 3 now. So we're recovering the CEMF, we're recovering the back EMF, we're using reactance in some cases on both sides to increase those potentials some more, and I haven't even put in the one-wire system yet as an additional system. So we're really using the environment to provide the additional energy flows, and using a little bit of traditional electrodynamics, but with a twist. So again, I just wanted to put the information out there, and essentially I have the little Bedini fan motor, which basically really sucks, I hate to say it, but it shows the demonstrations, but it doesn't beat the bike wheel and the multiple coil system. But if you have any kind of half-decent Bedini system, I really don't see why this system here wouldn't be able to self-loop, and you'd have to end up using the load eventually on an inverter, because it's very much like the Bedini condition with his last Ferris wheel system, where we're essentially not letting any of the 3 batteries go below 9 volts, and we're also using reactive in the system. So we're there's a lot going on here, folks, and it could only work, And of course, those who want to experiment more with the Bedini have talked about additional systems. Instead of running a fan blade, drive electrostatic discs and use the 150,000 volts for another system with displacement current against inert ground. And those we've experimented 90 volts, 100 volts, and a couple millisecond capacitive discharges at 22 UF or more. You're going to get a lot. The trick, folks, is to integrate several systems together. You want to recover the back EMF, the CEMF. You want to introduce as much reactance as you can in the system to increase the potentials at only the cost of the internal resistance. Again, it's not a free lunch, but we could work on efficiency. And with that said, what's a bonus of the reactive stage is what I've talked about. Batteries that are doing any kind of output work don't like to charge at the same time. So by deliberately messing with the phase, we're able to space out the input and the output pulse. And the reactance being 180 degrees out of phase, again, we're just using natural systems here to help us without making it too complicated. Just let nature do it for you. And this battery configuration, if the second one here has any higher voltage than any of the two, it'll pick it and start dumping its voltage and current in that battery without affecting with the rest of the circuit. This is exactly what we want to do. So that's what I meant when I was showing you the diagram earlier, you know, don't poo-poo all over it. I'm going somewhere with this. And this is what I wanted to show you. No isolation issues, but you know, a lot to swallow here, I understand. And with that said, folks, always looking forward to your comments and suggestions and ideas. Let's collaborate and talk about what needs to be said and what we can do to improve our systems. At some point, I would like to show this system, but I have yet to reproduce the real Bedini. Even the bike wheel one would probably have a good chance with this. So have yourselves all a great day, folks.